Hey everyone, welcome to part 4 of the Azure Master Class, and this one is all about resiliency for our services in Azure. So I want to think about, well, what are the types of resiliency? What are our options? Now, what are the constructs we have in Azure around resiliency? What do we have in terms of backups? And then just the various replication capabilities we have both from on-premises to Azure and kind of Azure to Azure. And then thinking about global balancing. Using Azure really can change the way we think about resiliency against any kind of regional failure. Instead of always being active, passive, saying waiting to take over if there's a disaster, actually just running it active in multiple locations. So what are our options around that? As always, if this is useful, please like, subscribe, comment, and share. In the description below, you can see the GitHub repository where I have kind of the whiteboard for this session. I have the slide handouts and any other materials I might have used, along with the overall playlist for this masterclass. So what are we protecting against? If I think about resiliency, we want resiliency for various reasons. I can think about resiliency against some kind of hardware failure. This could be a disk in the node that I'm running on. It could be on the node. It could be on the rack. It could be some big router in the data center. It could be the power supply, the communications. So it's going to take out the hardware that's hosting my service. It could be a software failure. Inside my virtual machine, something crashes. It could be my app. It could be the operating system. There's some kind of software failure. Maybe it's even a software failure at the fabric level. Azure rolls out some update that breaks things for me. So how do I have resiliency against that? Corruption. Now this corruption could be I write something, and in my code, corruption could be I delete a bunch of things. It could be I overwrite things with garbled data. It could be an attack that goes and encrypts my data, and now I can't use it. That really leads into the whole attack, denial of service type threats we have to worry about. And I also have to think about maybe not protection against, but maybe there's regulatory requirements. Hey, you can't host your services on a box with other people. You have to keep data for 7 years. So I have to think about all those things. So what can we do? It really breaks down into 2 categories. I can think about copying it somewhere else. So what this really means, I can think about, well, if I have my node kind of running my workload, that workload could be a virtual machine, and there's some concept of data, and I have kind of a block of data there. So one option is, hey, I'll copy it to another location. Somewhere else, there's some storage, and I can replicate that data to the other place. That data might be part of a virtual machine disk, it might be part of a storage account, it might be part of a database. And then if need be on that other side, or I can spin something up to then connect to that and offer it as a service. So I can think about copying things somewhere else. And I'm doing it kind of between regions. But if I think about, hey, copying it somewhere else, just from a local disk failure. So hey, instead of having one copy of my data in kind of this storage, I can really think instead, well, let's think about this as a bigger construct. In my storage, hey, I'll make this kind of a bigger picture, but I'll actually store multiple copies of my data over different physical disks, different back-end storage nodes, so it's resilient against some failure even just in that data center. So copies of data, copying it to other locations. So that's something I can do there. I can have previous point in time copies of my data. So here I could think about, hey, I'm resilient, I've got my data there, but I might also think about, well, if I change that data in some way, well, I want copies of how my data used to look. If you think about a corruption, if I have some logical corruption or an attack that changed my data, replication doesn't protect me from that. Hey, there's some mistake in my logic and I break the data, or there's an attack, it will replicate to all of the copies of the data. They're all corrupt. So I think about point-in-time copies or backups. Backup could actually be to a different location entirely. I might have kind of a recovery vault where I'll actually take the data and I can take the deltas, so just the changes, and now I can have a point of time a day ago, 2 days ago. So I have these delta-based copies, the changes to the data, but I can put those deltas together and really come to any point in time. So now if there was a corruption of some sort, gets encrypted or I mangle it, I can go back to 2 days ago and bring the data back. So they're not interchangeable. Replication is great if there's a failure. A disk fails, a node fails. Hey, I've got other copies close by. Something fails at a regional level. Well, I've got a copy somewhere else. And then if there's some kind of corruption or regulatory, I need to go back and show the data from 2 years ago. That's where these various point in times are really powerful and useful to me. So I can really think about those two options. And so I can mitigate against those various types of problem depending on what I'm trying to protect against. Hardware failure, software failure, probably a replication of some kind. A corruption at a logical level, I'm thinking point in time, backups, regulatory requirements, probably backups. Regulatory requirements around, hey, can't be on the same box as someone else. That's when we use things like Azure Dedicated Host, where I get the entire box, someone else can't be on that. Often you're going to have both. Very rarely is it, should I do replication or backup? It's probably going to be, hey, for resiliency purposes, I need replication, maybe within my region, between regions. I want backups as well, so I can go back to previous point in time. I'm going to talk more about these. So what can we do? Really, this just breaks down to, yeah, we copy it somewhere else. So that's replication. Have previous point in time copies. Well, that's backing the thing up. Now I say backup can also be snapshots. Some services have the ability to snapshot, like Blob, for example, Azure Files. They can snapshot at the same location as the source material and store point-in-time views. Blob, for example, they have things like a change feed, it has soft delete, it has snapshots, so I can actually roll back to previous point in times. So the big difference typically between these types of things is if I think about a backup, normally a backup is to some other location than the primary source of the data. A snapshot typically lives on the same media, the same medium as the primary. Because the snapshot's normally going to just store the delta, the changes. It's going to track the changes to the data so I can roll back. So if I have a snapshot, it wouldn't protect me necessarily if the entire storage medium I'm using failed. Whereas a backup vault that's on a separate set of storage, hey, I'd be able to go and roll that back. And very often when I think about backups, I probably want this backup at a different physical location than the source. So very, very common, we would kind of geo-replicate. I'm going to take my storage account that's hosting my backup and replicate it to a paired region hundreds of miles away. So if the worst case something happened, I still have protection from that. So as I mentioned, they're not really interchangeable. I'm not saying, oh, should I use backup or replication? They're attacking different types of problems. So if I think about hardware failure, probably going to be replication. Software failure, probably going to be replication. Additionally, software failure at a fabric level would, yes, mean replication, but typically it's going to mean replicating between regions as well. Microsoft has these pairings of regions we're going to talk about. But when I have the Azure pairs, they will never roll out the same update to paired regions. So if something went wrong when it rolled it out to one of the regions, I would fail over to the other region. It would not have got that fabric level update. Maybe it was making some core change to some API. It wouldn't break the other one. Corruption, probably going to be backups, snapshots, the ability to roll back in time. Attacks, there's such a wide range of types of attacks we can see. This could be some kind of isolated export. Again, if someone's attacking me and encrypting like WannaCry, they're pretty sophisticated. They might go and look at backups and try and delete the backup. So maybe some kind of isolated export, one of these kind of immutables. And a blob can do things like this. I can have immutable where I can't change it. I might have those immutable kind of copies of my data. Also things like distributed denial of service. Well, Azure has protections. There's a free basic one for any public IP, and there's a standard SKU that gives me more control over the policies of when that protection really kicks in. So there's replication, yes, there's backup, but for those types of threats, there's other things I want to do to mitigate against kind of a denial of service type attack. But if someone's just hammering my site through denial of service, well, maybe there's scale options there, but really I want to try and attack it at the source. Regulatory requirements is probably going to be backup in terms of keeping data for X amount of time as it was. If it was things about, hey, you cannot be on the same box as another person, that's things like Azure Dedicated Host, where I get the entire box to myself and I can fill it up with virtual machines that I am using. Now, before I can think about protecting, I have to know what I have and what they depend on. So understanding the systems that are key to my business is critical, as I have to protect them. I might have tons of systems in my company. I don't need to protect them all. I need to protect the ones that are part of my line of business, that enable me to do business and earn money and not go out of business. Many are made up of tiers, and I really have to understand when I have these tiered applications, where is the state? And what I mean by that is, sure, I might have lots of compute. I might think about, hey, I'm running some service. And I could think about at a very simple level, let's just say, for example, I have 4 web servers. They're all running maybe IIS, or it could be Tomcat, it doesn't matter. So they are what taking the initial entry point into my company. There's going to be some kind of load balancer at the front that has maybe that public IP address, and then it distributes the various requests. That's fine. That's kind of a front end tier. You'll often hear that kind of referred to. They might then talk to some middle tier. There could be a middle tier set of processes, maybe containers, something else. And then at the back end, there's probably some kind of database. This may be where the state is, and state is the data, things that change, the things I actually care about. So if this is kind of that back end, the database tier, in terms of what I have to protect the most, it's this. This is the thing I need to be replicating and backing up and putting somewhere else. Because if these all failed, if there's no state, if there's nothing I really care about in them, I can just regenerate them. With like infrastructure as code, I can redeploy that stuff. What I have to care about is, where is my data? So this right here, this is what I would really focus on. Replicating that thing, having backups of that, because that's something I can't recreate. If everything got lost, I can recreate things that don't have any state. The web servers just receive things, pass some kind of request to the middle tier. The middle tier does some logic that really stores and reads things from the database. That's the important part. This I can recreate. These are maybe virtual machines, containers. There's some shared image gallery, which is the image I use for the front end. There's a Azure Container Registry or something else that generates the containers. That's all fine. As long as those images are replicated somewhere else, which is super easy, I can regenerate all of this stuff. I can't regenerate data. So I have to understand, where is the state in my application? What do I really care about? I have to understand the services that it relies on, because they have to be protected as well. If you went back to that original picture, you can kind of imagine, well, yes, I'm drawing my system. Oh, okay, backwards. I've got this, but maybe there's some, I don't know, maybe Active Directory that it uses for ACLs of various things. So if AD wasn't available, then none of this would function. So I have to understand what are the various dependencies, so when I'm working out what I want to protect, I'm protecting all of the right things. Understand the nice to have. Sure, there might be a time tracking app I use for my company, but if there was a disaster and I wasn't tracking what I spent 8 hours on today, is that a problem? Probably not. How do I access these things though? Do I need to think about in a disaster VPN capabilities? Maybe it's remote desktops. COVID has been super interesting that people are working from home. Companies very, very rapidly had to work out, how can I let people remotely work? So how would I support that? Remote desktop farms, Windows Virtual Desktop in an Azure scenario, and point-to-site VPN solutions. I have to think about how I'm going to get to my services. So this all comes down to understand the access required. How would I enable this? Now you may look at these things and say, how do I work out dependencies? That's like super, super hard. So there are things to help you. Microsoft has something called Azure Migrate. Now obviously the word migrate means, hey, I'm going to move it to Azure. But Azure Migrate is free, and I can actually, as part of that, discover information about my systems, and it has something called Service Map. Service Map, through the various ports and protocols used, will work out dependencies between different systems. So I could run Azure Migrate and actually work out, well, this depends on this and talks to this, and it will help me. Azure Monitor is actually using that as well. Azure Monitor has Service Map. If I was using Application Insights, it has Application Map. Application Map looks at kind of the DLLs the app is using and the calls it's making to work out dependencies. So there are many things that can help me work out, well, what's talking to what. So I need to work out what I care about, where my state is, what they're dependent upon. Now, before I go any further, I want to quickly cover asynchronous versus synchronous replication, because this is super important to understand. Asynchronous is essentially, I have my primary copy. As soon as I write to that primary copy, I'm going to essentially acknowledge the transaction. So in data systems, when there's some write performed, it gets acknowledged. So I can think about, okay, I have my primary copy. This is writable. So I have my primary copy. Okay. So there's some client app that does some transaction, like a write operation. So that transaction writes some piece of data. Now there's also a secondary, it might be multiple secondaries. So I'll say there's a secondary. In an asynchronous scenario, as soon as this has written it, so step one is, hey, I want to do this transaction. It does the write, and then straight away as it does the write, step two is it will acknowledge it. So the app can carry on working. In the background, it will now copy it over to here. So what this means is, hey, it's very minimal impact, zero impact on the original app. It's getting that acknowledgement straight away, but this doesn't happen straight away, the copy to the other location. So there's a potential, if there was a problem at this location, I might lose that piece of data. But why it's really useful is, imagine I had a large distance between these copies. So this is a big distance. Speed of light, not even if it's speed of light over fiber routing, you get something called a latency. So if these were hundreds of miles away, this distance might take me, I don't know, let's just say 30 milliseconds. I can't wait that long to acknowledge the transaction. So in this mode, if I'm trying to replicate between distances, asynchronous is the good option because it's not going to impact the performance of my app, and hopefully it will get there pretty quickly. So that's asynchronous. So there's no impact on the primary performance, but there is risk of data loss. Synchronous is I don't acknowledge the transaction until it's written to the secondary. So this can impact the primary performance because now what we're going to do is if we think again, let me try to get on my board today. So here we might say, well, this time, yeah, there's another secondary. I'll do it down here. So there's a secondary here. But now what will happen is before this acknowledgement goes back, it will copy the data to the secondary, and then only after it's been written here and kind of that yes, it's done, would it now acknowledge back to the application. So this would be synchronous replication. So I'm going to write it to the copy, and only once it's confirmed to the copy do I tell the app it's actually been committed. So this is good if the distance is tiny, so I don't have that latency to impact performance, and there's no risk of losing data because I don't acknowledge the write until I've written it to the copy as well. But it really only works if the distance is small, i.e. it's the same location. So what you'll see is we often use synchronous replication within a location because the latency is sub-millisecond, and we'll use asynchronous between locations because we can't wait 30 milliseconds every single transaction we perform. So we have those two different types. And so async between sites, between locations, synchronous within a location. So just important to understand those concepts. So now let's talk about the constructs in Azure that I'm really going to focus on when I think about resiliency. So the first one is a fault domain. So if I think about Azure, we talk about this cloud service, but there really is no magic. Fundamentally, Azure is made up of racks of servers. So I have these individual nodes in a particular rack. And I can think about a certain rack as a fault domain. Let's say this is fault domain 0. And then I have another rack, again, filled up with servers, say fault domain 1, and then another rack. Now there's obviously more than 3, but I really can't be bothered to draw more than that. Let's say fault domain 2. Now these racks have things like a top of rack switch, they have power supply units. So within that fault domain, individual nodes could fail, a whole rack could fail because of some of those shared components like the power supply unit, like the top of rack switch. And I think about when I deploy, fundamentally my resource gets deployed to a certain fault domain. One of these things to give me those levels of protection. So that's kind of a core building block. So I can think about if I think about blast radius, things that can go wrong. If my fault domain had some failure, it would not impact things in different fault domains. So I want to try and, at minimum, distribute my workloads over multiple fault domains. And this is where availability sets come in. Now this gives me an SLA of 99.95%. And what availability sets do is I create an availability set within a certain region. So I'm going to go ahead and I'll say, hey, I create availability set IIS1, for example. And I then just add resources into that availability set. I'm going to say virtual machines. And what it will do is it will install them in a round robin manner over typically 3 fault domains. Sometimes there's 2, but normally you're going to have 3 fault domains. If I keep installing it, it's going to kind of round robin, distributing them over 3 different fault domains. So I don't tell it which fault domain, I just deploy it into the availability set. And then it will automatically distribute them evenly between the 3 racks that it's allocated. So these 3 racks are in the same region, generally in the same kind of facility, but it's not guaranteed because there's some stuff that goes on. So now I've got protection. If a rack failed, 2/3 of my workload would not be impacted by that because they are in different fault domains. Now they're in the same facility, so if the entire facility as a blast radius went down, they're all out. But at a node or rack level, I'm protected from that. Now there's also something within this availability set that applies to other things called update domains. And typically we can have from kind of 5 to 20. So I might be in 3 fault domains, but this might be update domain 1, 2, 3, 4, maybe I've got 5 different update domains. Update domains are used when the fabric, like Azure, has to update that host with a new version of the OS. It doesn't patch, it just reboots to a new version. That update domain would be paused for seconds. It's super fast. It uses something called VM-foo, preserving host update. So it pauses it, reboots to a new version of the OS. This is the fabric, not your VM. Azure's not patching your VM. This is the host that's running your VM. It reboots it to a new version of the image, and then it unfreezes it. So for that period of time, your VM is essentially paused. It doesn't move it between nodes, it just pauses it. This is why we need multiple instances of workloads. So during maintenance, my service is still available on the other 4/5, or if I had more update domains, whatever percentage that would be. Those update domains are also used if I have things like applications. I'm rolling out a new version of my app. But they live within there. But from a resiliency perspective, an availability set gives me 99.95% because it's distributing my workloads over 3 racks within that facility. Okay. The next construct is an availability zone. Now that gives us 99.99% SLA. So what availability zones are doing, if I drew those racks, well, the reality is those racks have to kind of exist somewhere. And fundamentally, they're living within a certain building. So there's a facility there. There's another facility with another bunch of racks. And then there's another facility with its bunch of racks. And these are exposed as kind of AZ1, AZ2, and AZ3. Now, all of these are within the same region. So if I think about Azure, all of these 3 AZs are in the same region. We just call it, for example, East US. A region is kind of a 2 millisecond latency envelope. So all those various AZs are within a 2 millisecond latency envelope. Now an AZ is logical. What I mean by that is there isn't a building called AZ1 or AZ2 or AZ3. An availability zone, if I think about what it's giving me, it's independent cooling, power, and communications from any other AZs. So if there was some failure of power or communications of this physical facility that powers that AZ, it should not impact AZ2 or AZ3. So my blast radius now, if I think about availability sets was fault domains or rack level, AZs, my blast radius is now a physical facility. Now an AZ may be made up of 2 data centers, 1 data center, it varies. But a different AZ would be a separate facility with those independent cooling, power, and comms. So I'm now protected if I deploy my services to 3 different AZs from any particular physical failure at a location basis, that particular facility. Now, I said they were logical. And the reason is those AZ1, 2, and 3 are per subscription. So if I had 2 subscriptions, AZ1 in my first subscription, maybe AZ3 in my second subscription, or maybe none of them. There might be 16 different facilities in a particular region. My subscription just gets mapped to 3 of them. a different subscription may be mapped to an entirely different 3 of them. So there's no correlation between AZs between subscriptions. They're just a construct to guarantee, hey, I have resiliency from any particular facility, power, communications, cooling, failure. So now I would think about, hey, I'm now going to deploy my resources. And again, they're still racks and nodes. I'm just not drawing them. Hey, I'll deploy a VM here. I'll deploy a VM here. And I had one up here as well. So now I've distributed over 3 different availability zones. Those update things still apply. They're still rolling out changes, those separations. But now if this facility went kablooey, power failure, whatever, 2/3 of my stuff is still running. Now they behave slightly differently. With an availability set, all I do is I deploy to the set. Azure automatically distributes them between the fault domains. Availability zones, I say deploy this to AZ1, deploy this to AZ2, deploy this to AZ3. I'm picking them. Now that's for virtual machines. Something like virtual machine scale sets or something that has zone redundancy support, it will distribute them for me. So that's the big difference. But if it was just like a virtual machine, I would actually have to pick which AZ. So I can show that if we jump over to the portal super quickly. And here, if I look at virtual machines, and we'll add a virtual machine, what we can actually see in here is if I look at the availability options, so I can see here availability options, so I've got that right here. Currently, it's no infrastructure redundancy required. Now I can select availability sets, or if the region supports it, availability zone. So let's change this to East US 2. And now I can pick availability zone. Notice availability zone, I pick 1, 2, or 3. I deploy which one I'm going to deploy to. And note here, not all regions support availability zones today. They're rolling it out to more and more, but not every region. So you'd want to go and check that. If I look at the list of Azure regions, it shows me which ones support availability zones. But if I picked availability set, I just pick the set. I don't pick which fault domain. I will see it if I go and look at an availability set. It will show me, hey, this VM is fault domain 0 and update domain 2, etc., etc. But I don't pick. I just say, hey, deploy it to the set. Notice I can't pick both. I can't pick a set and a zone. It's one or the other is what I can actually utilize as part of my deployment. So that's where I have those various constructs. So zone and sets. Obviously, zone gives me a better SLA. So if I can, I want to use availability zones. Then we have regions. Remember, I can use multiple regions. In my subscription, in the commercial cloud, there's loads of regions. And I can use those. So when I think about resiliency, sure, me here, availability zones gives me this great 99.99% SLA. But if there was some big natural disaster or something and the region goes out, I want to think about, well, there's lots of other regions. So maybe this is West US, and I would use the same constructs over here. So maybe it's AZs, availability sets. So I've got my AZ3, AZ2 for that region. And I would have my service running here as well. Maybe in a DR capacity, it would fail over. I'd have to make sure my data was being replicated, my state. Remember, I care about those things. There's other challenges to geographically distribute, which we're going to talk about. But now I deploy to another region, and they're protected against a regional level failure. And again, the point of these is, these are kind of hundreds of miles apart. Now, if both of them are down because of some natural disaster, the chances are we just don't care anymore anyway. Grim, but there's the reality of it. But there's all these pairings that are built into Azure, and again, I'm going to talk more about them. But these are the key constructs. Within a region, make sure I'm using availability sets or preferably zones. Make sure I'm also deploying to at least 2 regions So I can survive any kind of regional level problem. So I want to use those things. Now, let's look at this for a second. You may have workloads where I can't have two instances. All of my pretty pictures there, if you think about it, depend on being able to have more than one instance, more than one to spread over fault domains, more than one to deploy over availability zones. What if I have some older workload that's single instance? I can't run two. If I can't run two, I can't distribute over availability sets. I can't distribute over availability zones. And a really important point I meant to stress, do not mix workloads in an availability set. Availability set is just blindly that round robin. So if I mix different workloads in the same availability set through sheer bad luck, all of the IIS may end up on that fault domain, all of the domain controllers on this one, all of the SQL ones on that one. I create an availability set for every individual workload. IIS app 1 gets its availability set. IIS app 2 with a different bunch of servers gets a different availability set. SQL servers get a different availability set. Domain controllers, a different availability set. Never ever mix workloads. I want that distribution for the instances of that particular service. That's super important to think about. But if I do have those single instance workloads, go away. There is SLAs. So here I'm looking at the page and you can see, look, if it is a single instance workload, as long as I'm using a premium SSD, I get an SLA of 99.9. If I use standard SSD, well, then I get 99.5. If I use standard hard disk drive, I get a 95% SLA. So what this means is there's still SLAs, even if I'm kind of a single instance. Realistically, you'd use the premium or ultra. That gets you the 99.9%, at least it's 3 nines. But ideally, you want 2. There is also something called proximity placement groups. This is not a resiliency construct. It's kind of the opposite. A proximity placement group is designed to keep things close together. And I can use those with availability sets or availability zones. So the point of a proximity placement group is, hey, I'm trying to keep things as close as together as possible for low latency. So I can go ahead and the first thing I do is I create a certain proximity placement group. I create this PPG1. The first resource I put in it, if I put something in it that's in AZ2, it will then pin that PPG now exists here. And it's going to try and keep it as close as it physically can. So then everything else I put in it will be super close together in terms of latency. These could be VMs from different types. So what I'm going to do here is different clusters support different types of VMs. My most exotic, biggest virtual machine, I'm going to put in first to make sure my proximity placement group gets pinned to a zone and facility that supports that exotic type of VM. If I'm using my G series or my NV, I'm going to use that first, and then put in my Ds and my Es and my other stuff. So this proximity placement group will pin essentially that proximity placement group to the AZ with the first resource I put in it. So there is a cheat here. If I create a proximity placement group, put a resource in a particular AZ, if I then create another resource in an availability set, well, it's going to pin that availability set here as well, which means I'm putting an availability set in an availability zone, which is normally not possible. So I can cheat. Using proximity placement groups, I could now essentially create an availability set in a particular availability zone. But PPG, proximity placement group, is not a resiliency construct. I use it to put things really close together. I can use it with virtual machines. So here, if I go back to my create a virtual machine, and again, I'll switch back to something that supports availability zones, for example, I'll say AZ2. If I go to my advanced, what we'll actually see is proximity placement groups. I don't have any, but I could actually go and create a proximity placement group and put it in there. So now that would pin that proximity placement group to that particular AZ. So now anything else I put in that proximity placement group, including availability sets, well, it would now be in that AZ as well. So cool stuff. Those are the key constructs. That's super important to understand. They are the things we care about. Okay, So what supports these things? What supports availability sets and fault domains and availability zones and regions? Some Azure services are global. They're resilient against any particular regional failure. Things like Azure Active Directory, Azure Traffic Manager, Azure Front Door, the Azure Global Load Balancer. Those things are global. I'm not worried about protecting them from a regional level failure. That's not my problem. That's Azure's problem. Most are regional. Most, when I deploy a VM or virtual machine scale set or an app service plan or a serverless function or a standard load balancer or really any storage account, you name it, normally I'm picking a region. So I'm deploying it to a particular region. Now, when I deploy it to that region, different services will have different levels of support for those constructs, like availability zones that I just mentioned. Some of them are regional only. What that means is I say, hey, I want to deploy it to this region. I have zero knowledge of what facility it's putting it in. It's not letting me pick an availability zone. It's just deploying it somewhere. But you can be pretty safe betting it's in a particular facility. So if something happens to that facility, it will go down. Some of them will say zone redundant. Now in this model, it's deploying multiple instances of itself across different availability zones. So now if a particular facility failed, my service would be resilient. Some are zonal. Zonal means it's only deploying it into one availability zone, but it's going to let me pick the availability zone. So I can then architect accordingly, say, okay, well, I'm going to deploy these services to AZ1, these to AZ2, these to AZ3, like NAT gateway. VM scale sets I could deploy to a particular AZ or zone redundant. Depends on what model I want to use. I can actually look at this and it will give me an idea based on the current services, show me what they support. So here we can see for these key services, it's saying Z for zonal, I can pick the availability zone. ZR for if it's zone redundant, i.e. it's going to automatically distribute among the different availability zones. Now, one thing I would say, some of these are a little bit out of date, like AKS does have a zone redundant option. So just go and check on a per service level. But my point is, different services have different options of what they support. So it's important to understand those when we think about our architecture. Because what I don't want to do is mix them. What I don't want to do is if I'm architecting something, I don't want to think, okay, I have as building blocks availability zones. So I've got these, let's say, 3 availability zones. So I've got my AZ1, 2, and 3. I don't want to do a zonal deployment and say, okay, I'm deploying this AKS cluster 1 here, AKS cluster 2 here, and AKS cluster 3 here. So that's zonal deployment of AKS. Perfect. I'm then going to deploy an Azure standard load balancer. So that is zone redundant. So I'm good there as well. That's protected against any zone failure. That's going to balance between these different services. All good. But then I do something silly and I make these all depend on maybe something that's just in one of the zones. Or it's something that's regional that I don't even know where it is, but they all depend on it. Now, if that goes down, my brilliant, highly available architecture will now fail. I've put in some dependency on something that doesn't align with my zone redundancy. If I was using Azure Storage, well, I would make sure when I create my storage account, well, my storage account, there is a ZRS option. It's zone redundant storage. It's protected from any kind of zone failure. You see how I'm mapping these things. Imagine they're using NAT gateway for external network access. NAT gateway does not have a zone redundant option. It's regional, which I would not want to do here because I can't control it, or zonal. So what I would have to do here, well, I would deploy NAT gateway in each of them. However, NAT gateway works by assigning a subnet to use the NAT gateway. So now in my architecture, I'd need to make sure I'm using kind of different subnets. This would be more important if I was I couldn't do an AKS that's zone redundant, so it would all deploy to the same subnet. I would have to do 3 separate AKSs per zone, because now this AKS can go to subnet 1. This AKS could go to subnet 2. This AKS would go to subnet 3. So I'm making sure the only things in subnet 3 are in AZ3. The only things in subnet 2 are in zone 2. And now I could map this to its corresponding zonal network gateway. So do not mix and match. It's okay for something that's zonal to depend on something that's zone redundant. That's resilient. But don't make something in one zone depend on something in a different zone that's zonal. Like, don't make all 3 of these use the same network gateway in zone 2. If zone 2 goes down, these don't function anymore. Don't make them dependent on something that's just regional that I have no clue where it's running. So I have to understand what are the options of the components I'm using and architect accordingly to make sure that architecture is actually resilient. So here I'm looking at standard load balancer. Hey, I'll deploy it in zone redundant mode. Hey, the storage account it's using, I'll use zone redundant storage. It's distributed over 3 zones. As much as possible, if I can use PaaS services, use PaaS services. There's just less for me to manage, less for me to worry about. If this was a database, maybe it's Azure SQL database, I would use the zone redundant. Just announce that Ignite now general purpose support zone redundant. If it was maybe Postgres, I could use the flexible server and have a replica in another zone. I can do those things, but make sure I understand every component and don't put in some reliance on something that's in a different zone or is not zonal at all. I'm making myself weaker. I want to keep those components together. So make sure all the components match, and make sure we do spread out different instances so I'm resilient against any AZ failure, for example. What about multi-region? Okay, so great. I'm talking about within the region, I'm doing these things, but I said a natural disaster, a big tornado comes through and it wipes out all of the data centers. There's some big electrical storm and the power's lost on all of those data centers. What do I do then? So for true resiliency, I have to deploy to at least 2 regions. There is no concept of, hey, I'm in availability zones, I'm protected. There is no minimum distance guarantee for availability zones. Most likely, they're they can see each other. They're super close together. So there is no distance guarantee. If you've heard there is, there isn't. Azure regions are paired. Now this pairing is visible in some services. Azure Storage. If I pick the geo-redundant option, it's using these pairings, and I can't change them, for how it replicates the data. Azure Key Vault uses these pairings to have a replica of my Key Vault content. So if we look at these pairings, these are super important for a number of regions. So I can actually go and see which regions are paired. They're never outside of the geopolitical boundary. Well, that's a lie. There is one exception. It's Brazil. So if I go and look at this list, if we look at Brazil, well, Brazil replicates the South Central US. It's because there's only one region in Brazil, so it has to replicate outside its geopolitical boundary. South Central US does not replicate to Brazil. If we go and look, we'll see down the bottom here, North Central US replicates with South Central US. So things do not replicate outside of America to Brazil. It always tries to keep it in the geopolitical boundary. So Korea to Korea, Japan to Japan, India to India, Germany to Germany, France to France, etc., etc. So they have these regional pairs for the built-in replication. And it does more than just that. So these pairs are designed to, yes, it's going to keep the services hundreds of miles away. So we go back to this picture, the Microsoft pairings guarantees kind of maximum distance within the geopolitical boundary. But what it also does is if you think about when Azure rolls out updates, it will never roll out the same kind of fabric update to the paired regions at the same time. It will do it in series. See, we do it to, in this example, East US. Make sure it's healthy, make sure it's not causing a problem, and then roll it out to West US. So by using the Microsoft pairings, it gives me protection from some update that Azure makes from impacting my app. Additionally, if there's a problem, they're going to focus on getting that replica, the paired region, up as quick as possible, so I guarantee to at least have some on my workloads. Now, there is a counter argument to using the pairings, and it's if there was a real issue, you just have to think of capacity. Everyone's failing over to the same region. So in my eyes, I definitely want to use this region, but if I can, I'd like to be having another region as well, just so I'm kind of covering my bets. Many services actually let me pick what regions I want to replicate to. So yes, some of them, like Azure Storage, it has paired regions. Key Vault has paired regions. But even Azure Storage now, Azure Storage has blob level replica that I can configure. I could actually say from blob storage, hey, I've got my storage account, and my storage account has container 1 and it has container 2. There's a bunch of blobs in there. I can have a storage account over here in a different region and another storage account over here in a different region. Well, that could replicate over to here. This could replicate over here. It's asynchronous, it's different regions. But I can do that now. Blob has that capability. Azure SQL Database, I can pick the regions to replicate to. Postgres, pretty much all of those sort of database services let me pick the regions to replicate. So when I think about the state, I try and keep state out of the compute layer. I don't want it in my AKS environment. I don't want it in my app service. I don't want it in my VMs as much as possible. Get it into the database and then let the PaaS database services, if I can, handle that regional replication and use the AZs. And even if I can't, if it's in VMs, I have that control of how it's replicating. But yes, so those paired regions are useful in that they're going to do serial updates to the Azure Fabric. Now this could be active passive or it could be active active. And this is an interesting one when we think about multi-region. If I think historically on premises, if you thought about DR, you had your primary facility where you were doing stuff. And then you had kind of a DR facility where you hoped you never, ever, ever had to do stuff. This is where we kind of ran all of the resources. We had some kind of replication. And we had very little confidence this thing would actually work. But this was active. All of the work was going on here. Let's zoom back in again. So this was the active one. Replicated here. If there was some huge disaster, then we would fail over, we'd start things up, a bunch of things wouldn't work very well, but we did active passive. Because maybe this was like a warm standby, a cold standby, we weren't paying a lot of money for it. So active wasn't really even an option. Now, in the cloud, there's hundreds of regions. So I've got a region here. And there's another region over here. I can just as easily run 6 instances of something here as I could run 3 there and 3 over here. The cost would be the same. Paying for 3 VMs or 3 worker nodes in my node pool or whatever that might be. It hasn't cost me any more money. The benefit here is I've got the same scale. I've still got 6 instances. I've now got even better protection because instead of having 6 spread over availability zones or availability sets, now I've got 3 on 3 availability zones here and 3 in another region. Also, my users might be here and here and here. So now not only have I got better resiliency because I've got regions built in, but now they're going to get a lower latency. They can go to the ones that are closest to them. Now, they need a geo-balancing solution. I'm going to talk about that. But this is a nice option. I like this. So why wouldn't I do this? And it really comes down to that state, the data. If you think about this model for a second, and let's assume that there is a database. And this is where all of the data is. And let's say I'm going to replicate to a secondary. So I'm going to do some kind of replication. But remember, between regions, it's generally asynchronous. And in any kind of relational model, the way it would work is this one would be writable. This one would only be readable. So if I had my compute running in both of them, the way it would have to work is these here, great, they can read and write. These ones here, well, they could read from this, but they would have to go and do all their writes over to that one. So how many writes did the apps do? How latency sensitive it? Could it support 30, 50 milliseconds of latency every time it did a write? If it's read heavy, maybe this is fine. Also, it'd have to guarantee it got the most recent write. So if it wrote over here, if it tried to read it back straight away, it'd have to make sure it read it from here as well, because this one's out of date, doesn't have it yet. That asynchronous replication hasn't put it there. So I have to understand my app. I have to understand its tolerance, and I have to, can I even support these type of architectures? So the active model is great if I can handle the data, because typically only one of them is writable. Now there are features in like Azure SQL Database and other databases that give me listener pointers so I know which one is writable. If this went down, this would take over and become the primary, and now it's writable. So these would now point to this to go and do writes. But it's really my data that's going to drive, can I run active? There are other options though. These are kind of relational. Azure SQL Database, Postgres, there's things. There are solutions that enable multi-write. But in an Azure world, ideally, we would get to Cosmos DB. Cosmos DB is kind of a NoSQL, not only SQL. It has different consistency models. And as long as it's not strong consistency, I am guaranteed to have the same read from any write. I can write to any region that I've set up a replica of my Cosmos DB database. Now the consistency is commonly session. So what that means is these would all share a session. They would read and write from their copy, and then asynchronously, as quick as it can, it would replicate it over to other regions. That would work if the app only had to guarantee it was getting the latest write from things in its location, but could eventually catch up to other locations. So if I can switch, I can get to a multi-master level. So if I went to a Cosmos DB, they'd be reading and writing to their local copy, they'd be reading and writing to their local copy. That's generally going to be some app changes. For most companies, they're not there. So if the decision to go active depends on this. How can my app behave and support only one writable copy in a different region, but maybe just get my reads from here? But it is now an option. It's generally not going to cost me any more money. It just depends on my app and my data model if I can support those kind of active scenarios. So Cosmos DB would give me multi-write capabilities. But again, it's not a relational database. I'm going to change the models of how I'm doing things. I need to make sure all of the core elements are available in all the regions. Again, dependencies. It's no good replicating my data, my state, and then I forget about some key dependency. Think about what I mentioned earlier. Think about what I said about state. So in this model, we draw this again. Let's imagine for a second my app is fairly simple. Could be multi-tiers, whatever. Let's imagine, for example, I'm running an active passive. And I have a whole bunch of IIS web front ends. This could be like a VM scale set even. and then I've got my database, okay? Now in another region, I have the copy of my database, and it's asynchronously replicating to it. But this is active, this is passive. Nothing's going to this other location. If these are stateless, be it VMs, virtual machine scale sets, AKS, app service plan, why would I bother having them running over here on the passive one? I'm just paying money for no good reason. If these are any kind of stateless and I'm using like a declarative technology to create them, infrastructure as code, why bother replicating them over here at this point and having them running and paying? Remember, I'm paying for the compute charges of these things. Database is replicating. These are built off of some image. They're virtual machines. Then within this region, I'm going to have kind of this shared image gallery. So this shared image gallery. So that's where it's my custom image. If it's the Microsoft provided images, they're already replicated everywhere. Maybe it's just a repo with my PowerShell DSC or my Puppet or my Chef to configure them. Maybe it's my app code is in a container or something. I just have to make sure it's replicated. There's a copy of my gallery or my repo in that other region. Things like GitHub, automatically they have spokes and it replicates my content. If it was a shared image gallery, I can set replicas. I need a replica of my gallery over here as well. If it was an Azure container registry, if they're containers, I can have a repo over here. So now if there's a disaster, it would go and create them at the time of the disaster and connect it to the data that's being replicated. I don't need to pay to have the compute sitting there doing nothing. As long as it's stateless and I have the right declarative configurations that I can build them out super easily, why bother replicating VMs that have no state? Why have them sitting there? Create them at the time of the disaster. It may take a few minutes extra to spin those resources up. Chances are in a true disaster, you have a few minutes. You're going to have things like recovery point objectives and recovery time objectives. So when you talk about those things, you have recovery point objective. Recovery point is how much data can I lose? Because it's asynchronous. You may lose stuff. RTO is how long to be running. So I have an RTO of 2 hours. In a true disaster, I have 2 hours to get this up and running. Recovery point objective, I can lose 5 minutes. So it's async, it's a true disaster. It was unplanned, I didn't see it coming. I can lose 5 minutes of data because it's async. If it just went kablooey, sure, I may lose data. It's unavoidable. Any kind of unplanned disaster failover, if something just disappears, I'm going to lose data because it's asynchronously replicating. If you have workloads that you cannot lose data, it's that critical, then there's some kind of synchronous has to be going on. So you're going to pay a cost for the impact to the app performance because you cannot commit it until you know it's in the other location as well. So you're willing to take the hit on the app performance to get synchronous replication between the regions. But I understand these RPO, RTO constructs because that can actually impact how I'm going to do those things. But again, if there's no state, create them at the time of failover. Just make sure you have the things required to create them. I have the image that I create them off of. I have the repository that has the app code, that has a declarative configuration. I have the container registry that has the container image. Make sure everything is there that you depend on in the event of the disaster. Make sure there's the ability for people to connect and use it. Maybe those VPN connections, maybe those Windows Virtual Desktop. Think of everything I need in the other region to actually be able to use it. Some resources cannot move between regions, e.g. public IPs. Public IPs are regional. I cannot move a public IP from one region to another. So if I failed over, it's going to have a new public IP. So we would have to hide that. We would have to have something on top of the public IP so it's invisible. Maybe it's a DNS name, but there's a DNS timeout, DNS records live for an amount of time, or is a different IP that's global that can point to different IPs that are regional. I have to be able to balance between the regions. So this drives into this. If I want active-active, or even active-passive, and the IPs are going to change, I have to have some way to balance between the regions. And there are a whole bunch of different options. Azure Traffic Manager, Azure Front Door, Global Load Balancer, and DNS. So let's think about this for a second. I want to simplify this picture. I have just 2 regions, but it would scale out. It doesn't matter how many regions I have. The point is, in each of these regions, I have a public IP. Public IP1, public IP2. Now, they might then point to, they're on standard load balancers that point to tons of different resources, but that's the outward facing service. But they're different regions. So this is kind of region 1, this is region 2. Now there's me. Very happy, got no hair. Used to it, wear a hat. I want to use these. I don't want to, well, take a step back. Technically, if the app was smart enough, I'm running an app and I'm writing this as a client app. This could be a server app. Maybe the app just knows IP1 and IP2. The app has the logic to go and check, can I get to IP1? If I can, I'll use it. If I can't, I'll try and go to IP2 instead. So I could build that into the app that it is just aware of all of the possible targets and it would try and use them. So I could think about the way to do that is it could just be DNS. I might just have a whole list of records that say for this service, hey, there's IP1 and IP2. It gets returned and it will try them. Active Directory works that way. Active Directory, when I find a domain controller, it looks for a service record for _LDAP._TCP.domain name, gives a whole list of them, it tries them until it finds one that works. So there is an option there, DNS, and I could update this. Maybe it only points to IP1. If this goes down, I could have an automation that changes it to point to IP2. There's something called a time to live. Machines cache records for an amount of time. If I set it to a low time to live, say 5 minutes, within 5 minutes, it would see the new address and point to the new record. DR terms, 5 minutes is probably fine. The smaller you make the time to live, the quicker it will realize something's down, but the more often it's pinging your DNS server. But let's say we don't want to take that approach. As kind of our worst case, yes, we could do that. So the next thing we could do is Azure Traffic Manager. And the way Azure Traffic Manager works is it's a DNS-based solution. And what happens is I'm going to have a DNS name, .trafficmanager.net. That name will resolve to the DNS names of these services. Now, it can also point to things running on my premises, but I'm focused between Azure regions right now. And the way this would work is me as a client is going to look up, hey, this DNS name, .trafficmanager.net, I would hide it. I would put a vanity name. So I would say, hey, www.savtech.net, point to this traffic manager DNS name, and it would then resolve based on different types of balancing options that I can select. A common one is performance. Based on my location, it would point me to whichever one, it would resolve to the name of whichever one was closest to me. So it would point me to region 2. So Traffic Manager is DNS based, doesn't care about the service. It's not giving me any kind of offload or acceleration. I go to a name and it resolves it to whichever one is closest to me. If I use performance, it can do active primary, it can do probes to make sure they're healthy. It could round robin. It can base it on geography, so it keeps me in a certain geography, goes to this version. I have a bunch of different options. So Traffic Manager is DNS based. That's the key point. So it's going to really work with anything, but it's not really giving me a whole bunch of extra benefit other than it resolves to something. My next option are all kind of working in similar ways. If I think about the Azure network, we have this great big Azure network, And these regions are connected to this great big Azure network. There's also a whole bunch of edge sites, might call them points of presence, all throughout the world. Tons of them. So what we have is something called the Azure Front Door. So what Front Door does is for HTTP and HTTPS only, it gives me a new IP address that is anycast. So for my service, I'm going to get IP3. IP3 is actually available. It's broadcast on every single one of those points. It's anycast. That's the whole point. So now what happens is no matter where I am, so now I'm over here, when I go to that IP address, I'm going to go to whichever point of presence is the closest to me. In this case, I hit this one. With Front Door, this is actually going to terminate my connection. So it's going to do the TCP establishment, it's going to do the HTTP, the SSL, it can do the SSL offload. Then over the Azure backbone, it will go to whichever one is closest, get the content, but it will get big chunks of content rather than tiny little bits at a time. Get a big chunk of content, cache it here, and then feed it to me a piece at a time. So not only is it caching, so it's going to speed things up for the second person, it's grabbing big blocks of content so there's less trips. It's terminating my connection close to me, so it's going to overall improve my connection. Now, because of this termination, I don't see the true client IP address for my service that's behind here. But one of the nice things about Azure Front Door is it's just working with services on the Azure network. Things like Bing have been using this for a long, long time. So anycast service, I can have now resources in tons of regions, and it's going to use whichever one is available. Again, it's doing probing to make sure it's healthy, and it will use that one and get it to the user. So the user gets the best possible experience. And again, all that traffic is going over the Azure backbone, which again is going to be super efficient, really focus on lowering those latencies. But it only works for HTTP and HTTPS. What about if I've got something that isn't HTTP, HTTPS, and I don't want to use DNS? So what they kind of have just announced is the Azure Global Load Balancer. So now I'm back to, again, I'll just say I've got two regions for now. And I've got that kind of public IP1 and IP2. And these are actually in front of standard load balancers. What I can now do is have kind of a global load balancer, which has kind of a different IP address that points to the regional load balancers. And once again, this is anycast. So now when I go and hit across all those different points of presence on that Azure network, I'll go to whichever one is closest to me, and then Azure will redirect me to whichever load balance on the back end is the regional load balancers that it's pointing to that is closest to me. And I can maintain my client IP. So my IP address here will actually get sent through to those back-end load balancers. So they'll see my true IP address. And again, it works for things outside of HTTP, HTTPS as well, because it's layer 4. So if I have HTTP, HTTPS, ideally use Front Door. If it's not HTTP, HTTPS, then I can use, now, this is in preview though, the Azure Global Load Balancer, but these have to be public IPs, they have to be public facing. Or if not, I can do DNS based with Azure Traffic Manager. So all of those solutions are basically going to balance between different regions. They're all doing kind of probes to check, hey, is it there? Is it healthy? So this is how I can have things in multiple regions and balance between them. That's really kind of that key point. So we covered a lot there. Okay. Use infrastructure as code. Don't go and create things from the portal. It's going to ensure consistency. It's immutable. If I'm declaratively defining what I'm deploying, it's always going to be the same. I can easily rebuild things. I can use policy to enforce consistency between deployments to make sure it's always going to look the same way. So I really want to focus on not using things in the portal. Use templates. use Terraform, use containers, use declarative technologies to build things out. And then when I talked about, hey, don't have to replicate necessarily, just build it as you need it, this is going to enable that. So I have state. Okay. How do I replicate it? So I can do native application. Some service might have multi-master replication capabilities. There might be a DR type replication in the application. Maybe I can use some hypervisor, Hyper-V replica. VMware had kind of the site recovery manager. Maybe it's an in-OS level kind of replication. Maybe it's a storage-based replication. Something like storage space direct incompatible with storage replica. Maybe I just restore a backup, recreate the VM. Remember, this is if there's state. So I can't just recreate from scratch, I need the state back. Or I can not have any plan and I just leave the industry in disgrace. We're generally trying to avoid that one. That's not choice one. Really try and stay away from leaving industry in disgrace, never a good thing. So remember, if there is no state, I keep saying this, it's super important. Do I need to replicate it? Just have the process to recreate it. So what I'm saying about this, so let's take a step back. Forget about Azure for a second. If I was on premises today, if I was on-prem and I had a workload, okay, and then I had my kind of DR location over here, and I had another set of workload. So I have storage at my primary. Well, I have storage at my DR site. I might replicate using that, something like SRDF in a cluster. I could have storage replica inside Windows 2016 and above. Then I have the hypervisor. There's a hypervisor over here. So I could replicate the hypervisor level, like Hyper-V replica. Then I have some OS running inside. Well, maybe they're saying I can replicate inside the OS. And then I have my app. Maybe I could replicate at the app level. Something like SQL, always on availability groups. Something like Active Directory, domain controllers. The further up I go, generally the better the experience. If the app is doing the replication and the failover, it's going to know at what point the app was when there was the failover. It's going to fail over the quickest, the cleanest way. As I go further down, it gets a little bit maybe murkier. If it's just the storage replicating it, well, it starts up and this bit's been marked dirty. It has to go and do some consistency checks. It's not as great of experience. So generally there's different levels I can replicate, and I try and go as far up as I can. Now if you think about Azure, so now there's Azure. I can really apply the same logic. I could create a virtual machine, and fundamentally a VM from a state perspective is the storage, the managed disk. So that's my storage that's connected to the virtual machine. Now that could be up and running, and I could have the app running inside that virtual machine, and I could do app level replication. I could have SQL here, SQL there, domain controller here, domain controller there. That's going to give me the absolute best performance. But realize with Azure it's a little bit different. I'm now paying the compute charge of that VM running all the time. Or I could maybe replicate at the OS hypervisor level to storage. The VM doesn't have to be running. Now what I'm paying for is something called an Azure Site Recovery License. So it's not as good, it's not going to fail over as quickly because this thing isn't up and running, but it's going to save me a bunch of money because I'm not paying a compute charge anymore. So we make kind of these trade-offs. It depends on the workload. If this workload is my tier 1 database that needs to be up as quick as possible, a domain controller at least one, I'm probably going to do an app level replication. It's worth the dollars for the compute. And remember, in a true disaster, I can probably have a little bit of downtime. This could be a smaller instance compute, And if I actually fail over, I could stop it, resize it to a much bigger instance, and then start it again. So it costs me more compute, but it's normally small just to accept the replication. I just have one domain controller, I could quickly clone them out to get more. But if it's not a tier 1, it says, then maybe, hey, I'll do it the OS, the hypervisor, save the compute money, and just replicate it to the storage. And then if there's a disaster, then it goes and creates a virtual machine. Then I start paying the compute charge. Then it connects to the disk and it's up and running for the duration of the disaster. So I have kind of those different options available. But think of the layers. And then in Azure, because I pay compute charges based on what I'm consuming, realize there is a difference. So there might be some workloads that even if I could replicate the app, it's just not worth it financially. I'll just use Azure Site Recovery and replicate. And again, remember, if there's no state, I don't need to replicate that VM at all. Just make sure I've got the image required or the declarative configuration stored up in Azure somewhere, and it gets updated if I update it here by change control. And I can just recreate the things if I actually need it. So that web front end with no state, I don't replicate those VMs. I'll just recreate them if there was an actual disaster. So what about virtual machine replication? Now from on-premises to Azure, there's actually 2 different solutions by Azure Site Recovery. If I'm running Hyper-V, I can use Hyper-V Replica. Essentially, I can, hey, I've got my on-prem location. I'm running my Hyper-V server. I've got my virtual machines. And what Hyper-V Replica essentially does is at the hypervisor level, it does a replication at 30 seconds or 5 minutes to these virtual hard disks. So that's, again, Azure Site Recovery. In the event of natural disaster, well, that's when it would create the VM and attach to it. Or if I'm not running Hyper-V, let's say, for example, I'm running ESX, or it's just a physical box. So now, essentially on top of that ESX, I have an OS instance, or I just have an OS instance running on bare metal. So what it does is there's a service, there's this mobility service. And if I think about an operating system, fundamentally you have kind of a file system and a volume driver. Then the app talks to the file system. So it says, hey, it goes down through those layers. So what this does is in OS, it injects between the file system and the volume driver this mobility service. And what happens is now, as those writes go through, it actually splinters the write. So it still goes through to the volume driver and the storage, but now it takes a copy of that write and it puts it on kind of this appliance thing, and it's kind of a joint configuration and process server. So there's this process here that essentially takes it and sends it up to the cloud. There's a hidden master target that we don't see, and it writes those to a VHD. So it does that conversion from like VMDK, because it's not seeing a VMDK, it's just seeing writes to a disk, ESX or physical. And so again, that's ASR, and this is continuous. So it's not on some kind of replication interval, it's just streaming it as kind of quick as it can. So that works from VMware or an OS anywhere. This could be a different cloud because it's inside the OS, doesn't care where it is. Now the important point is the fail back. So for Hyper-V, it does a reverse replication back when I fail back to populate this. For these, it can only fail back to ESX. So if I was replicating from a physical OS, I can't fail back to the physical bare metal hardware. I have to fail back now to an ESX VM. So just realize that. That's why you'll see things like, yes, I can use this from other hypervisors, other clouds, but I can't fail back to them. So like if I was migrating to Azure, hey, I could use this technology. It's free for 31 days. So for 31 days, I can use these replication things. This is how I used to do migration. But now there's actually an Azure Migrate service. Azure Migrate is free for 180 days per instance. And actually with Azure Migrate, it's not the focus of this topic, But for Azure Migrate, because it doesn't have to worry about failing back, it's a migration service. For ESX, it can actually use snapshots of the hypervisor to populate the virtual machine. So I don't have to do the in-guest if I'm migrating. So if I use Azure Migrate, a different solution, it can actually use ESX snapshots. And again, it's free for 180 days. But in terms of replication, I want to be able to fail back. There's different solutions for both Hyper-V, ESX, and physical. Azure to Azure, it also supports. And funnily enough, for Azure to Azure, it uses that same ability service. So you'd think, oh, it's Hyper-V in Azure, it uses Hyper-V Replica. It actually doesn't. So if I have a VM running in Azure, so I've got this VMs running, it's connected to the VHD. Again, it's the OS. What it actually does is it installs an extension that puts the mobility service in. So remember that file system and the volume driver, that mobility service? It uses that to replicate to another region where it has the VHD. And again, there's these internal process servers and master targets, but fundamentally now it's taking that and writing it over there, and that's ASR. I can even ASR to a different availability zone in the same region if I want to. That's now an option. So if my VM is deployed to an availability zone, I can replicate to a different availability zone. It doesn't have to be a different region anymore. So that's another option. So to replicate between regions, if there's state in this thing, I can use ASR to replicate the VM to the other region. Now, once again, my other option would be if the app has its own native capability of replication, I could just run a VM here, run the app connected to its VHD, and replicate at the app level. So that's the app replication. Realize the difference, I'm paying compute charge all the time. So again, it's that balancing act. Depends on my requirements, depends on the app, what it supports, what I can do, if there's state. Because once again, if there's no state, just create it over here if there's an actual disaster. But it's your job to think about this region level failover. Don't think, oh, okay, it's in the cloud, I'm good. If this region goes down, Microsoft will bring it up. No, they won't. You have to think about these things. If I'm deploying something to a region, my responsibility, be it a VM, app service plan, AKS, database, storage account. I pick GRS to make sure there's a replica to another region. It's on me to make sure I'm thinking about and using these solutions. Also, a nice thing about the ASR is I can actually have recovery points. So what recovery points give me is not just the latest state. I can actually say, hey, I want to fail over, but I want to fail over to how it looked 4 hours ago. And I can do these multi-VM consistency groups to say, hey, these 4 VMs, I want to fail them over, but they all have to be the same point in time. Maybe there's some synchronization between their databases. I can't have one 2 minutes ago, one 3 minutes ago, one 7 minutes ago. They all have to be at this exact moment. So I can define these VM consistency groups. So now I can fail over to a point in time and all 4 of the VMs would start at the same thing. That works for the on-premises ESX as well, that in-OS agent. I don't think it works for Hyper-V. If I need it for Hyper-V, I would use the in-guest agent. So that would kind of be my option. Don't pick one. And what I mean by that is there's all these different options. Pick the one that makes the most sense for that particular workload. Don't say, hey, well, yeah, this app has this replication capability, but this other one doesn't. I'm going to use the in-OS, so I'll use in-OS for everything. Use the one that makes sense for my requirements. That's going to give me the best experience. Don't use lowest common denominator. There may be some extra considerations from using different technologies, but we're going to use things like recovery plans. That's part of Azure Site Recovery. I create a plan, and that plan can say fail over this group of VMs. Then run this script. Wait for this manual action, so let's go and pull a big lever. Then go and migrate this set of VMs. Run this script. So I can do different things. I can orchestrate. I give myself a big red button that I can push that will do the entire failover process. I don't have to simplify it just to get the lowest common denominator so it's the same technology. I will have to consider the cost though. This is disaster recovery. This is something I hope I never ever have to do. So yes, maybe there is an app level replication for tons of these things, but my recovery point objective says, and my recovery time objective says, I don't need to fail over that fast. I really need to try and minimize my cost, because app level requires the compute to be running. Remember, if I want to do app level, it has to be running. Whereas if I use Azure Site Recovery, it doesn't, or on-prem. For this one, it's not the most important data in the world. I don't have this time. I'll just replicate the storage level. I can cluster. If I have workloads, I can cluster in Azure. If I'm using things like SQL always on, in Azure in hybrid scenarios, I have to be able to use Windows failover clustering. My recommendation is to use Windows Server 2019. The challenge is a lot of clustering like to use IP addresses that move between OS instances. We cannot do that in Azure. So the solution in the past would be, hey, look, we'll put a load balancer. The load balancer would own the IP, and then we'll have like a fake IP in the virtual machines. But now we have this concept of a distributed network name. This was introduced in Server 2016 for some resources. In Server 2019, even the core, the cluster name object, can be a distributed network name. What that means is it's not a specific IP address anymore. It will register all of the IP addresses of all of the cluster nodes, so I don't have to have some IP address that can drift between nodes anymore. It really, really simplifies my clustering experience. I can use Cloud Witness, so I can use a storage account as the witness for my cluster, for the cluster I'm going to go and create in Azure. And there's even shared disk support. So if I do need shared storage, ideally we try and stay away from that. I'd rather replicate the data. But if I have to have shared storage, now we have shared disks. I have the ability to set a max shares number on like premium disks. The bigger the disk, the more people that can connect. I think the smallest one is 2. I think that's a P15. I think a P30 is 5, a P60 is 10. So then I can have multiple VMs connecting to the same disk, and I can have a shared disk within my cluster. So I have that ability. Again, I've gone long. I apologize. We're nearly done. Bear with me. So disaster recovery. I have planned and unplanned. There's really 3 types. Planned. Hey, look, there's a storm coming. I should probably fail over. So I know it's coming. I do a preemptive failover to my disaster recovery location. I should not have any data loss, or at least no unexpected data loss. I can cleanly shut things down, fail it over, start things up. It's a planned amount of downtime. And again, I really shouldn't lose data, because I'm going to stop the process here, start it on the other side. Unplanned. Hey, look, our data center's gone. Big storm went through it. Well, you're going to have unplanned downtime. You're going to have data loss, unless you're really, really lucky. That asynchronous replication, there's probably going to be some stuff you lost. And then there's test. People don't do this very often. You really should. I don't want to find out I'm missing a key component when it actually matters. Do tests of my process to make sure I know, hey, I'm missing that thing. I need to go and fix it. Make sure in my change control process for production, I'm adding this new system. I need to make sure I add that to my DR location as well. Backup. I've been really focusing on sort of the replication, the architectures for resiliency AZs, but don't forget about backup. So at the simplest level, Azure has backup services via Recovery Vault. So Recovery Vault is a portion of storage, and I can use that to store backups from various services. VMs is an obvious one, but there's others as well. So these can be used to actually give me app consistent backup. So if you think about an app consistent backup, ordinarily I can think about, well, I have my OS instance, virtual machine, whatever, and I have my app. And my app is running and it's constantly doing reads, writes to the file system. if I just did a backup of the storage at a point in time, the app might be halfway through doing some write. So I would get something called a crash consistent. It's a frozen copy of the storage, but if I actually try to use it, it may say, hey, this is in an inconsistent state, I have to do this repair. What app consistent does is in Windows, there's something called VSS. This is the volume shadow copy service. There's actually an extension we have in Azure. So if now Azure Backup, when it takes a backup, it actually calls via the extension VSS. VSS calls VSS writers that are created by the apps. What it does is it tells the app, hey, flush everything out to disk and then pause, quiesce any future changes. Now, at this point, it can take the copy. Now I'm going to kind of take a backup of this state because the app has flushed everything out to disk and is pausing. Takes probably sub-second, but I think 10 seconds is the max. And then it releases it, and then the app can start writing things again. There's even something for Linux. So Linux has some pre and post scripts that can get called to flush out Linux apps as well. So I can get app. So this is now app consistent. That's what we want. That's kind of the thing we like for our backups. We know we're getting a good clean backup because it's calling, it's flushing all that good stuff out. Again, Linux has these own pre-post scripts to make sure we get that. So with Azure Backup, we can use extensions to get the app consistency. We can then recover it as we need. I can restore the VM. I can restore files from the VM. Now, I can restore files from the VM, but this backup is not app aware, with the exception of SQL. SQL is a special extension to understand the databases. But if I had other apps like SharePoint, I can't restore a SharePoint item. If I want app-aware restoration, I have to do an app-aware backup. So I'd run the backup agent inside the guest OS so we could see the apps that were installed, see the application's constructs. It's Delta-based storage with many, many recovery points. So if I think about this backup, when it does this backup, then I can think there's this great big recovery vault. So the recovery vault. So recovery vault is storage using Azure storage that can be geo-replicated to another region. And it's only storing the delta. So it's taking what has changed and it stores those deltas at many different recovery points. So I have lots of different recovery points in here. And I can set what those recovery points are. So if I actually go and jump over for a second, if I go and look at recovery, so I've got my recovery services vaults, I can set policies, and let's look at what I have. And under my backup policies, I can see I've got an annual retention 5 years. And what you can see here is super cool. I can say, hey, I want a daily. I think I can have up to 2 backups a day. So I can pick when I'm doing a daily. I can retain instant recovery snapshots. That's actually going to keep it on the local storage so I can restore super, super fast. So not only is it copying it to the recovery services vault, it's actually keeping it on the local storage as a snapshot so it can restore instantly. It doesn't have to copy it from the vault. But I can say, hey, look, keep a daily for 14 days. Then keep a weekly for 4 weeks. Then I want to keep a monthly for 12 months. And then keep an annual, down here at the bottom, for 5 years. So by setting this policy, Azure will actually take care for me keeping those. So if I had those regulatory requirements saying keeping 7 years, great, I can do it. And it's only storing the deltas between those recovery points. So I pay for the storage, I'm only paying for what's changing between those. So I have all those retention settings, and those vaults can be local, zone, or geo-redundant. Additionally, some services have their own backups. They don't use Azure backups. Things like Azure SQL Database, Postgres use their own capabilities for the backup to store those things. Some utilize snapshots, like Azure Files, snapshots to the local storage. So this is interesting. Azure Backup can orchestrate the snapshot. So I can actually back up Azure Files from Azure Backup, but it doesn't copy the content to the vault. All it is doing is creating snapshots on the Azure Files that can then be used, but it's not actually storing them separately in the recovery services vault. I'm using that orchestration feature of Azure Backup to control creating the snapshots, which are in place, previous point in time views of the Azure file system. Azure Blobs has snapshot. It has soft delete. If I delete it, I can undelete it. Azure Blob has object replication I talked about earlier. I made it a custom solution. If I have my Azure files and I want it replicated to another region and I can't use GRS because it's premium, I'm doing something else, well, I can write things with things like AZ copy to do delta-based copies. Managed disks, I can't set up as replicas. Normally I'd use ASR. I'd replicate it that way. But again, I can create a snapshot of a managed disk and then I could replicate just the changes to the managed disk to another region. So I have all these different options. We covered a massive amount. Again, I apologize. I'm utterly useless at keeping any kind of time. There's a lot to cover. Key takeaway from this: make sure your services are resilient within the region. Use the right constructs. Make sure I'm not depending on something in a different zone. Don't introduce a point of failure that's in a different construct than where you are. I always want to use something better. If I'm zonal, rely on something in the same zone or zone redundant, and then have independent copies in different zones. Regional, maybe I'm active passive, depends on my data, what I can support in terms of that replication. Normally it's single write, then I have readable secondaries. Can I support the latency of writing, and then make sure I get the latest read from my app if it's in another region? Geo-balancing solutions. Don't forget backup. Replication is not a replacement for backup. If I corrupt my data, that corruption will just replicate. So I really hope this was useful. Please, questions below. I'll keep an eye on those. And until the next one, take care of yourselves.